Are we live? Yeah, good morning. Good morning, Poonima. Good morning, everyone. Hope you are doing great. Good morning, Shakeen. Okay, today again I'm in front of you bringing another interesting and crucial topic of physics, mechanics, that is relative motion. Relative motion. So the topic of our discussion is going to be relative velocity, relative motion today. Yeah, I think other friends are also coming slowly. Yeah, ultimately it's a weekend. So tomorrow we are not going to have any session. Tomorrow it's Sunday. You must be enjoying Sunday at its fullest. But at the same time, uh, as I say that on everyday basis, you must follow the rule of revision before you sleep. Similarly, on Sundays, your plan should be similar to it, that whatever you have learned throughout the week, whatever you have, learned new things, done new problems, you have grown up with the subject, you have evolved with the subject, whatever the situation was, that you must be giving a revision touch on Sunday. All right. In short, whatever we have learned, we must be revising it thoroughly on Sundays. But you still can get a lot of time. Enjoy the Sunday at its fullest. Morning to evening, wake up at relaxed time, have a healthy routine. If you want, you can go out for some movie, read some good books. But doing all this also will not take the entire day. You'll be still left with some good number of hours. In those good number of hours, I'm not telling you to do anything new, but I'm definitely telling you to revise whatever you have learned throughout the week. Okay, we are just trying to get more disciplined day by day, so that slowly our every single effort must be counted towards our goal of the NEET exam. All right. Yeah. Good morning, Manideep. Good morning, Chandana. Yes. Chaliye. So today we are going to start with this topic of relative motion in kinematics. Before I say anything else regarding this topic, I want you to fit it in your brain, fit it in your head that relative velocity or relative motion is just another technique to simplify the crucial situations. What will be those situations? We will talk about them. But ultimately, it's a tool, it's a technique. All the questions that can be done with relative velocity can also be done without relative velocity. All right. It is just a tool or technique to simplify the analysis of our motion, specifically the motion in which observer is also moving in common terms, I would say. So ultimately, it's a technique. It's a tool to simplify your numerical, simplify the analysis of your situations. Even if you don't want to use this technique, then also your questions can be done. All the problems that can be done with relative velocity can also be done without relative velocity. All right. But obviously, there will be a beauty attached to this technique, which will simplify the big questions into simple steps. Big solutions will be minimized into one step or two step, like that. So there will be specific models. All right. We will understand how to analyze the situation, like when to think about the relative motion, number one. Number two, what if the same question or situation we deal with relative and we also deal without relative? Okay, we will compare. Then we will see particularly some models in which the use of relative velocity will make their dealing easy. For example, two bodies are moving, extended bodies are moving, and then they are crossing each other. Two particles or bodies are moving in random direction and then they are approaching each other, or then they are separating from each other. So what will be the velocity of approach? What will be the velocity of separation? What will be the minimum time, or what will be the time of minimum separation of the two bodies anywhere in the air? It can be in 1D or it can be in 2D. So first of all, we will start our discussion with a relative motion or relative velocity in one dimension. Then we will extend our discussion with two dimensions. All right. And then later on, there will be two major models in which students always feel a doubt in. One is the riverboat problem, other one is rain umbrella problem. Since these two models are very famous, everyone has heard about it, but everyone is not so comfortable about it. So in our next interaction, that's on Monday, in our next interaction, I'll be taking care of the riverboat problem, and subsequently, in the next to next interaction, I'll be taking care of the rain umbrella problem, cyclist problem, fluttering of flag problem, wind problem, ship models. There will be many models. Understood? So today, next day and next to next day, these 3 days, we are going to talk everything regarding the relative motion. Can we start now? Let us start with the introduction and then the usage, where we can use it. All right. So before I talk about this, let me write it for you. The problem models based on relative motion. Problem models based on relative motion. Number 1, time of crossing. Time of crossing. Two bodies are moving, extended bodies, two trains are moving, maybe parallel to each other or maybe anti-parallel to each other. They have their individual lengths, they are moving with their individual speeds. By taking care of these parameters, in what time they will cross each other, that will be the time of crossing. Or else there will be an extended body, say call it a train, it is moving over a bridge. So both are extended. Train also has some length, bridge also has some length, but bridge is not moving this time, only train is moving. So in all such cases, how to find out the time of crossing, that we will learn today. Second model is going to be time of approach. Time of approach or meeting. Time of approach or meeting. That will be the second model. All right. Number 3, there will be riverboat problem. As I mentioned, that this we will take separately. Riverboat problem we will take separately. Then we will have rain umbrella problem. Rain umbrella problem, this also we are going to take separately. Okay. And then we do have here as flag fluttering problem, flag problems plus cyclist problems, flag problem plus cyclist problems. Okay. And at last we will be talking about the ship model. All right. So these are going to be different types of models. So before starting the today's discussion, I just portrayed everything in front of you. Now, what do you mean by model, sir? I mean that there is a case study, and in this case study, there can be different things which could be asked to you. Now everything can be there depending upon the model. For example, in riverboat problem, there are 2 types of questions. In riverboat problem, 2 types of questions which we will be dealing later on. Question number 1, what will be the time to cross the river? Question number 2, what will be the drift produced in the swimmer or like whosoever is crossing the river, maybe the boat. Okay. So question number 1, time to cross the river. Question number 2, the drift produced in riverboat problem. Similarly, if we talk about the rain umbrella problem, then in rain umbrella problem, there are 2 types of questions. Question number 1, with what speed the raindrops will hit the person? Question number 2, how to hold the umbrella in order to protect yourself from the rain? Prevention from getting wet or protect yourself from the rain. So 2 types of questions are there. Similarly, in ship model, there will be 2 types of questions. In ship model, they will be asking you question number 1, what is the minimum separation between the ships? Number 2, time to attain the minimum separation. So for example, for your convenience, let me write this riverboat problem, the 2 questions in front of you. So here, time of crossing, the question is find the time of crossing. Time of approach, the question is determine the time after which they will meet. Okay. But in riverboat problem, the first question which they are asking you is time of crossing. Time of crossing of the river. time of crossing TC. And the second question, what they generally ask is drift. And obviously they are connected to each other. Drift. Then in rain umbrella problem, they are asking two different questions. First is speed of hitting. Speed with which the raindrops hit the man. So they are asking you the velocity of rain with respect to man. The velocity of rain with respect to man, its magnitude, means instantaneous velocity's magnitude will be the instantaneous speed. Velocity's magnitude here is going to be instantaneous speed. And the second part, how to hold the umbrella. How to hold the umbrella. All right. In this how to hold the umbrella, I would like to give you a reminder that if you are trying to find the angle with the vertical, then vertical component of velocity must be coming in denominator. I have repeated it several times in our previous session. I am repeating it for you once again. And I'll take it another time in rain umbrella problem. That is the third session of relative motion from now. The rule is, with whichever axis you make the angle, that component must be coming in denominator. With whichever axis you make the angle, that component must be coming in denominator. So phi v will be, angle with the vertical will be tan inverse Vx by Vy. Tan inverse Vx by Vy. I can show you geometrically why it is happening, but I am right now not interested in drawing the diagram, making you feel that. No, you just remember it in words. With whichever axis you make the angle, that component must be coming in denominator. So here also, I would say, if you are interested in phi h, phi v means angle with vertical. Angle with vertical. All right. And here I would say that phi h means angle is with horizontal. So with whichever axis you make the angle, that component must be coming in denominator. So it is Vx horizontal. Vx comes in the denominator. So it is Vy by Vx, or vertical by horizontal. Is that simple? So two questions in the riverboat problem. The entire next lecture will be based on these two discussions only. Two problems on the rain umbrella model. Then there will be ship model, and ship model, again there are two problems here. The first part is minimum separation. Two ships are moving randomly, or two buses are moving randomly in space in a plane 2D. So minimum separation, x minimum, what is that? Okay, minimum separation. And the second is time to attain the minimum separation. Time to attain the minimum separation. I hope you have understood what I am trying to teach you on this slide. I told you I started today's discussion with a single simple point that today we are going to study relative motion. It's a different way of analyzing the motion of the object, and especially it comes into the picture when your observer itself is moving. But what I want you to remember is relative motion or relative velocity topic is just a tool or a technique to simplify the analysis of the situation or dealing with the crucial problems. All the questions that can be done with relative velocity can also be done without relative velocity. But sir, when it comes in the exam, question comes in front of us, how to decide whether to do the problem with relative velocity or to do the problem without relative velocity. So obviously these are the models which are listed in front of you. If a question comes from any of these models, which we are going to discuss today also, in our next session also, and in our third session also, in the continuity related to the relative motion part. So when we are going to look at these models, obviously the question comes from any of these models, you have to directly use the technique of relative velocity. All right. So now let us start the discussion of relative velocity. Keeping in your mind, there are two things. Number one, it's a tool or a technique. So any question that can be done with relative can also be done without relative. Number two, one by one, we have to see what type of problems are there in different models. Rain umbrella and riverboat, we have separate sessions. Next session, riverboat. Next to next session in this bridge course will be rain umbrella. And rest of these we will keep dealing from today itself. I hope it is clear. Any issues? Yeah, any of your doubts you can mention in the live chat session. I'll definitely answer it here. Can we get live classes, sir? Yes, you are already getting live. I'm live here in front of you. It's not a recorded session. It's a live interaction so that you can keep asking your doubts and we'll keep answering them. Sir, when the live classes are going to start? Okay. Sir, when the, yeah, okay. Okay, so all the new learners, good morning everyone once again. Now let us start with our discussion of relative motion. Relative motion, those were the problem models. Now, what is the concept of relative motion? A very basic concept. See, I would say there is an object here. Two objects are here, A and B, and they are moving in random direction. This is moving with VA vector and this is moving with VB vector. Okay, VA vector, VB vector. Okay, they are moving. So these velocities are basically their velocities with respect to ground. These velocities are their velocities with respect to ground. So VA vector is here and VB vector is moving like this. All right. I want to analyze the same situation in two cases. Case 1, I want to see the relative velocity or relative motion of A with respect to B. With respect to B. With respect to B, or you can say according to B. A relative velocity of A with respect to B. Relative velocity of A with respect to B means here A is serving as an object. Whose velocity you are observing? Object's velocity. And who is observing, or according to whom? So you want to see the relative velocity of A according to B. So who is the observer over here? B is the observer. I repeat, I am driving my bike on a road and there is another bus which is moving in another direction with some random velocity. So there is my velocity and there is bus velocity. So if you want to observe the bus with respect to me, according to me, so I am the observer and bus is the object. And if you want to observe the biker with respect to the bus, which means bus is the observer and this biker is an object. All right, makes sense? The language, relative velocity of A with respect to B means whose velocity, that is going to serve as an object, with respect to whom, according to whom, that is going to serve as an observer. All right, so now I will say here velocity of A with, now first of all let us see how to find that, how to analyze that. So I would say the situation is that A is moving in this direction with VA vector and B was moving in this direction with VB vector, but now your observer is B. Your observer is B, so do one thing, imagine yourself like a teeny tiny observer and you go and stand over B. Imagine that this is you who is standing over B. All right. Now the issue is that before the topic of relative motion, we were happy when we ourselves as an observer were at rest. Once again, we are happy when we as an observers are at rest. But here in this situation, we are not at rest. So we are not that happy. How to make ourselves happy? When we are bringing ourselves to rest. Once again, our habit is to always observe the situations keeping ourselves at rest. So here the B as an observer was not at rest. Let's do one thing, bring B to rest. So how you can bring B at rest? Bring B to rest. How you can bring B to rest over here? So you will say I'll give minus VB vector over here, minus VB vector. So if this was VB and you supply minus VB here, so what you have got, you have come at virtual rest, virtually at rest. But the issue is, whatever velocity, whatever change you have made in any one part of the system, the same changes are to be made in all the other parts of the system, which means after giving this B platform as minus VB, the same minus VB must be provided here also. The same minus VB must be provided here also. So you will say, after bringing yourself at rest, whatever the velocities are remaining with the rest of the world, that is the observation of the world according to me as an observer. Once again, let me put it in words. There are 10 things moving randomly, 10 objects moving randomly. Now, out of those 10 objects, one is the observer. Out of those 10 objects which are moving in random direction, one is the observer. So how to deal with such situation? Whosoever is the observer, bring it to rest. In order to bring it to rest, whatever change you have provided it, the same changes must be provided to the remaining 9 particles. And after bringing the observer at rest, whatever is left with the remaining 9 particles, after bringing the observer at rest, by doing this, whatever is left with the remaining 9 particles, that is the observation of the 9 particles, that is the motion, relative motion of the 9 particles with respect to that 10th particle that is serving as an observer. Did you get that? Once again, I am saying, listen to me very, very carefully. Let us consider that we are considering a system of 10 objects which are moving in random directions. Out of these 10 objects, if I make any one as an observer, then for the convenience, I will try to bring the observer at rest by providing its negative velocity vector. But the condition is that whatever velocity you give to any one of them who is serving as an observer, the same velocity must be given to the remaining ones. The same will be given to the remaining 9 particles also. After bringing the observer at rest, whatever is the velocity of the remaining 9 particles, that is the relative velocity of the particles with respect to the observer. So after bringing B at virtual rest, whatever is left with A, that is the relative velocity of A with respect to B. Relative velocity of A with respect to B. So I will say here, relative velocity of A with respect to B. How do you write that? You write it as VA comma B. VA comma B. So that is equal to, after bringing B at rest, what is left with A? So you will say it was already having VA and you provided it minus VB. It was already having VA and you provided it minus VB. So what you got it as VA vector minus VB vector. VA vector minus VB vector. Be very, very careful. Whenever you write VA with respect to B, the first one is serving as an object. Its velocity will come as it is. Second one is serving as an observer. Its velocity will be added negatively. Or you can say its velocity will be subtracted. So once again, the rule, the final formula is feeling and everything is okay, sir. But what to remember? This much feel we can't enjoy in the exam. When the question comes in the exam, obviously we are supposed to solve it, right? So the thing is, velocity of object with respect to observer is always given by velocity of object minus velocity of observer. Velocity of object with respect to observer is always given by velocity of object minus velocity of observer. If you are dealing with 2D cases, then you are supposed to substitute both the vectors in terms of I cap, j cap. If you are dealing with 3D, I cap, j cap, k cap. If you are dealing with 1D, then you can stick to the convention along the x-axis, forward positive, backward negative, upward positive, downward negative, but those are the values. Forward, backward, upward, downward, positive and negative. Those are the values which you are going to substitute according to sign convention in this. Those are the values which we are going to substitute according to the sign convention in this, and that will be our next target also, a relative velocity in one dimension. So don't worry, I'll emphasize on that. But as of now, I hope you have understood something. Let me one more time rewrite it for you. Case 2. Once again, we are rediscussing. Let us change the language this time. This time, see, Both the bodies are moving. Both the bodies are moving. Which one is object and which one is observer, sir? That either depends on you, your mood, or it depends on the examiner. So how it depends on the examiner, sir? In the language of the question, we will see. How it depends on our mood, sir? In the different variety of models, we will see. In these different variety of models, we will see how, depending upon our mood, we can take anyone as an object and anyone as an observer. And in the language of the questions, we will see which one to take according to the examiner, which one to take as an object and which one to take as an observer. So first of all, for a while, let us assume that examiner mentions it, or let us assume we are specific about our mood, that yes, we know which one to take object and which one to take observer. So I'm just using another language to make you more comfortable. Relative velocity of B with respect to relative velocity of B with respect to A. Relative velocity of B with respect to A. The moment you write it, whose velocity you are writing? You are writing velocity of B. If you are writing the velocity of B, the B will be serving as an object. The B serves as an object, and A serves as an with respect to, according to whom? According to A. So A is serving as an observer. A is serving as an observer here. Just a moment. So all right. So now, so if we are looking for velocity of A with respect to B, that story is over. Now we are looking for velocity of B with respect to A. So this is A. It was moving with VA vector originally, and this is B. It was moving with VB vector originally. Now what do? You go and stand here, because your observer is at A. So A itself is an observer, or observer is standing at A, both means the same. See, so VA is here, but we are happy when the observer is at rest. So if I want to bring the observer at rest, I'll write it as minus VA. I'm going very slow today because I'm trying to make you feel what is the concept. Then we will see different models. Okay. So this is VA vector. This is minus VA vector. Doing this, you have brought your observer as at virtual rest. It is not in reality at rest. Okay. But it will be observed at rest. But the issue is, whatever change you have brought in any one part of the system, the same change must be propagated to all the other parts of the system, which means the same minus VA is provided to this also. The same minus VA is provided to this. Now, after bringing the observer at rest, whatever is remaining with the rest of the world, that is the observation of the rest of the world according to the observer. Means out of A and B, after bringing the observer A at rest, whatever is the net velocity left with B, that is the observation, that is the relative motion of B with respect to A. So I will write here velocity of B with respect to A. So velocity, when I write velocity of B with respect to A, B is the object. B is the object and A is the observer. So velocity of object with respect to observer is always velocity of object minus velocity of observer. Or you will say with B, VB vector was already there and you provided minus VA. So what is the formula finally? VB vector minus VA vector. Again the same thing, if the velocities are given in vector direction, vector component form, then you can express that in I cap, J cap. But if you have to deal in 1D, then formula must contain a minus. Because of the formula, there is a minus in between. But once you substitute the values, that also you have to substitute according to sign convention in one dimension. Means if you are using or solving the question in y-axis, upward take positive, downward take negative. And if you are solving or dealing with a question in x-axis, then forward substituted positive, backward substituted negative. But there is always a minus in between because of the formula. I hope that is clear for you. So how to use that formula? I have told you according to sign convention, we will see how to get that formula. Now onwards, you can remember that velocity of object with respect to observer vector is always given by velocity of object vector minus velocity of observer vector. Velocity of object minus velocity of observer. So the conclusion is, I'm writing the conclusion here. See, the conclusion is that velocity of object, velocity vector of object with respect to observer is always velocity of object vector minus velocity of observer vector. Substitution must be done as per the sign convention. Is that clear? Chandna is writing no sir clear, means it is clear or it is not clear. Okay, Niranjan, Manideep, any doubts dear Chetan? Any other doubt to anyone? We have just introduced the concept of relative motion. I hope you understood when to apply, when to think about this concept, sir. When two or more objects, all of them are moving. Particularly in our NEET syllabus, two objects are moving, both of them. So you can go and stand on any one and analyze the other one. When you are going and standing on any one and observing the other one, the relative velocity of B with respect to A or object with respect to observer is always given by velocity of object minus velocity of observer, or you can also write it as velocity of object vector plus minus of velocity of observer vector. Minus of velocity of observer vector. You see, this you are already taking care. This you are already doing in all the cases. Have a look. Take 30 seconds. Have a look and just go through all of that and try to rewind my words in your head. Try. Let me know if any doubt is there. Then we'll start with some problems or some more discussions in Monday. Just have a look. Rewind. Try to rewind my words in your head. I hope that's clear now. Understood the concept of relative motion? All right. Now, let us talk about relative velocity in one dimension. Relative velocity in one dimension. Case 1. Objects are moving, like in one dimension there are two cases only possible, na? That they are moving in the same direction or they are moving in the opposite direction. So objects are moving in same direction. Objects are moving in same direction. All right, this is the case 1. And case 2 will be objects are moving in opposite direction. Case 2, objects are moving in opposite direction. Okay. So I'll see them one by one, what is happening and what will be the conclusion. Opposite direction. All right. Let us see that diagrammatically. What is happening here? I would say that there is an object A who is moving with VA vector, and there is an object B who is moving with VB vector. All right, and they want you to find out the relative speed. When I'm writing relative velocity in one dimension, basically I want to find the relative speed here. Finding relative speed. So how to find out the relative speed, sir? The logic is very simple. You find out the relative velocity, take its magnitude. Find out the relative velocity and take its magnitude. You will get the relative speed. Instantaneous velocity vector's magnitude is always instantaneous speed. So I will say here, what is happening? Here what is happening? See, velocity of A with respect to B. Suppose I want to find that velocity of A with respect to B. By the formula, it is always VA minus VB. VA minus VB. Now substitute the values here. Substitute the values. So you will say that that will be equal to VA vector. VA vector, since by diagram all of them are moving forward and forward. So by sign convention you can write it as plus VA. Why this plus, sir? And why not there is an arrow again? Because direction I have already considered that A object is moving in forward direction. That's why I should be writing it as plus VA. Minus B is also moving in the forward direction. I should be writing it as plus VB. So that is equal to VA minus VB. VA minus VB. So relative speed is given by, its magnitude you will take both sides. So definitely I can say relative speed is given by the difference in their individual speeds. The difference in individual speeds. All right. So when the objects are moving in the same direction, their relative speed is given by the difference in the individual speeds. And same situation if I observe here, that suppose A object is moving like this with VA vector and B object is moving like this with VB vector. Diagrammatically, if I go ahead for the sign convention, can I say here VA with respect to B? VA with respect to B will be, by the formula it is VA vector. By the formula it is VA vector minus VB vector. That is the formula. The minus sign is because of the formula. But now you have to fit the values as per the sign convention. See, according to the diagram, A is supposed to be moving forward. So that is plus VA minus, it is minus VB. All right, minus will be plus. So it is VA plus VB, which means that is, you will say relative speed is given by the sum of individual speeds. Relative speed is given by the sum of individual speeds. All right, sum here. So what we can conclude, we can feel it also. You have experienced it, that suppose you are sitting in a train and train is moving in the forward direction. On a parallel track, another train is there who is also moving in the parallel direction, same direction. Then if the two trains are moving in the same direction, their relative speed with respect to each other slows down. But if the two trains are moving in opposite direction, they become relatively faster. While observed from one train, the other train moves very fast. Okay? Yes or no? So basically, if the two trains or two vehicles are moving in the same direction, then because of the same direction, the relative speed is given by the difference of the two. It will be reduced. And here, if they are moving in the opposite direction, the relative speed is given by the sum of the two. Definitely, they will cross faster. So if relative speed is more, time of crossing will be less. They will cross faster. If relative speed is less, time of crossing will be more. They will take a good time. It will be delayed. The process of crossing will be delayed in comparison to the sum. I hope that is clear. Any doubt, anyone? So this slide, even if I don't write all this parallel, anti-parallel, and I directly ask you, can you feel that? Tell me when it will be faster. In opposite direction, observation will be faster, or in same direction. I think everyone can feel that and answer me appropriately. Then why I took this much of time to explain these things? Because my another agenda of writing it in front of you was to emphasize on the fact that whenever you are dealing with the problem of relative velocity, it is always velocity of object with respect to observer. Anyone can be the object, anyone can be the observer, but by the formula, it is always V of object vector minus V of observer vector. By the formula, it is minus. At the end, it can be minus, or at the end, it can be plus. That depends on the direction of the individual speeds, individual velocities. That depends on the direction or sign convention used. Is that clear? So formula wise, it is always velocity of object minus velocity of observer. But conclusion wise, it may be added or it may be subtracted. Both the conclusions are in front of you. I hope that's clear. Any doubts to anyone? No doubt. Everything is clear, I think. Right. So, as I mentioned already, that the first model is going to be time of crossing. I'll again talk further. I'll keep talking for all 3 sessions, and for, since it is a technique, it will keep coming in different topics, associated with different topics also. So I'll keep talking about them. But right now, let us talk about this first model for today. That is time of crossing. Time of crossing. Remember, in the opposite direction, the relative speed is added. In the same direction, relative speed is subtracted. Let us talk about the time of crossing. Illustration 1. Example 1. Or let me take directly the case. First case. First case is there is a person who is moving with V man. Alright. And he is supposed to cross the bridge. He is supposed to cross the bridge. Obviously, the bridge will not move, and this is the length of the bridge. This is the length of the bridge. LB, let me write it for simplicity, LB, and it is VM, velocity of man. Alright. If someone is asking you what will be the time of crossing here, so I will simply say the time of crossing will be, this man has to run over the bridge. So the total distance it has to travel is LB. By the speed with which it will be covering this distance is VM. VM, suppose assumed constant. It is moving with a constant speed, so that's why it is. Sir, what if it will be having the accelerated motion? Slowly we will club. But as of now, let us assume that everything is moving with a constant speed. Assuming constant speeds for this slide. Okay, assuming constant speeds. Now, number 2, suppose I take the case in which there is a train. There is a train which is moving, this is the front part, which is moving in the forward direction with VT, and there is a thin tree. There is a thin tree. The train has to cross this tree. The length of the train is LT. The length of the train is LT. So crossing means the last or the front part, the engine part will also come cross the tree, and the last part of the train will also cross the tree. In that situation, the time of crossing is the total distance the train has to travel to cross this tree is the length of the train itself, and with what speed it was moving, Vt. See, basically every time I am applying the formula, time is equal to distance upon speed. Time equal to distance upon speed. Sir, how that is a relative velocity topic? Why you are giving these examples in relative motion? Here, one of the things, either object or observer, is not moving here. But actual relative velocity beauty will come into the picture when both of them are moving. Alright, so I will take that from the 4th case. Let me give you some more familiarity with the 3rd one also. Now in the 3rd one, I'll club the information of the first 2. That let us suppose this is a train whose length is LT, and it is moving with VT, and it is supposed to cross a bridge. It is supposed to cross a bridge whose length is LB over here. LB. Alright. So what will be the time of crossing? Can you try answering me in the comment section? Can you try answering me in the comment section here? Yes. The total distance it is supposed to travel is LT plus LB. By the speed with which it was traveling is VT. By the speed it is traveling is VT. Let me take another example for you. Number 4. What is happening here? We are just taking this example. In this, there is a train. There is a train of length LT moving in this direction with VT, and there is a parrot, there is a bird, and it is moving in this direction with VB. Okay, so they are moving in opposite direction. In order to cross the bird's body is not having an effective length. The effective length which is to be traveled, the bird must be coming on this part. The bird must be coming on the last edge here. Then only you will call it a crossing. So in order to cross, the effective distance which is supposed to be traveled is the length of the train. But who is trying to cross? Both are trying to cross. Alright. And since they are moving in the opposite direction, If the bodies are moving in the opposite direction, their relative speeds must be added or subtracted. The bodies are moving in opposite direction, so it will get faster or slower relatively. Added or subtracted? Yes, they are added. So what I'll say here is that time of crossing will be equal to LT by VT plus VB. And if you would be moving in the same direction, then definitely you will take the difference in the speeds. Difference in the speeds. Number 5, it is the length of one train. Suppose the length of one train is L1 and it is moving with V1, and the length of another train is L2 and it is moving with V2. Crossing is possible only if V1 is greater than V2. If they are moving in the same direction here, the crossing is possible only if V1 is greater than V2, suppose. Then only the time of crossing can be written as the total length effectively which has to be traveled is L1 plus L2. L1 plus L2. Any part of one train relatively has to travel L1 plus L2 to cross the other train. With what speed? Since they are moving in the same direction, definitely the relative speed will be given by the difference in them. So that is bigger minus smaller, V1 minus V2, V1 minus V2. And the last part, I hope now everyone can answer appropriately, that if this length is L1 here, it is moving with V1. If this length is L2 here, if it is moving with V2, then definitely the relative speeds will be given by the sum of them. If relative speed will be given by the sum of them, the time of crossing will be L1 plus L2. The effective distance which is supposed to be traveled is the total length, L1 plus L2. But since they are moving in opposite direction, the relative speeds must be added. And if you are adding them, then which one is bigger and which one is smaller, it doesn't matter to you. So that is V1 plus V2. Is that clear? I hope the first model of time of crossing, assuming constant speeds in front of you, is absolutely clear for you, right? And I hope you have understood how and why we are calling it a problem model based on relative velocity. Just have a look, take few seconds to review all the parts and give me a thumbs up if you have understood. If not, post your doubt in the live chat session. Definitely I'll answer it. Faster, Navdeep, Channa, yes. Faster, it will be Chandu, yes, absolutely correct. Very nice. I hope everyone has already understood this model now, right? Okay. Now, let me take you to the confusion of relative velocity and effective velocity. It's a nice confusion. Why I'm calling it a nice confusion? Because if we are dealing with it today, then definitely this confusion is not going to bother you in your journey ahead. Okay, so should we deal with it today? Yes, let us see. So relative velocity and effective velocity. So I will say velocity of object. We know the velocity of object with respect to observer is always equal to velocity of object vector minus velocity of observer vector. Or in other words, you can also say VA with respect to B can be written as VA vector minus VB vector. But sir, these VA and VB vector are what velocities with respect to what frame? It's not necessary that these are the velocities. It's not necessary that these are the velocities with respect to ground. No, it is necessary that these must be the velocity with respect to, say, any third random frame of reference, C. Anything can be C. It may be ground, it may be anywhere else. It may be a moving frame. Means one object is moving randomly, another object is moving randomly, and I am the one who is observing these two. I myself will be moving, maybe moving randomly. Okay. So the observer or the ground, when you say that the VA and VB individually are with respect to ground, then you are restricting the ground that you should be at rest. But I am saying it's not necessary, dear. It's not necessary. When you are writing VA with respect to B, It's VA minus VB. These VA and VB may be with respect to any third frame. Let us call it C. Okay, let us call it C. So this is one formula you got here. One formula you got. Okay. Or further what we can write, this implies, I'll just rearrange. I'll write VA with respect to B plus VB with respect to C. That is equal to VA with respect to C. VA with respect to C. So A on B, A is moving with respect to B, B is moving with respect to C. Then that will give you how A is moving with respect to C. How A is moving with respect to C. This is another formula. This is another formula. So the above one is the formula of relative velocity. Relative velocity. The above one is the formula of relative velocity. Basically, this relative velocity formula will be used when both the objects are moving. When both objects are moving and we want to judge the motion. Try to feel the words what I am writing. We want to judge the motion of one object, of one of them with respect to another. Means I'll prefer to write it as two bodies or particles are moving. So when two bodies and particles are moving anywhere and you want to stand on any one and look at the other one, then in that case you will use the relative velocity, which involves a vector subtraction in the formula, minus. But if you just rearrange it, you will get a vector addition. This is what? This is effective speed. When object A is moving on B, anywhere, vector it is. When B is moving over C, so how A is moving over C, that you will get. Which means a monkey is moving over the roof of a train. The train is moving with respect to platform. For example here, I'm saying velocity of monkey over the roof of train, vector, it may be moving in forward direction, it may be moving in backward direction, okay, positive, negative, anything, but you have to write vector. Velocity of monkey with respect to train plus velocity of train with respect to platform. Velocity of train with respect to platform. If you add these two vectorially, vectorially means along with their plus minus sign, you will get the effective speed. Of monkey with respect to platform. Try to understand the feeling behind both the topics. This was relative velocity. You just rearranged it a bit. What you got is the effective velocity. Because I am going to use these terms in our further discussion. And this effective velocity will come into the picture when you say when objects are moving with respect to over each other. When object 1 or body 1 is moving on 2 and 2 is moving on 3, not necessarily in the same direction, then the effective value, and we want to observe the effective motion. Resultant motion. So basically, I am not saying that ultimately they have to be positive only, they have to be in the same direction. No, I'm saying by the formula, relative velocity will be given by vector subtraction. By the formula, effective velocity will be given by vector addition, and both are not different topics. That is just rearranged in one step. But the feeling behind, like the feeling in your heart and mind when you use these vector addition and vector subtraction in the question are going to be different. So I'm repeating it one more time. Listen to me very, very carefully and try to feel my words. I'm saying when two objects are moving randomly and you want to observe any one of them standing on the other, means anyone is the object and anyone is the observer, then to understand the situation better, you will use relative motion, which involves a vector subtraction here. That involves a vector subtraction. And if there are multiple frame of references or multiple platforms, body 1 is moving with respect to 2, 2 is moving with respect to 3, 3 is moving with respect to 4, and you add all of them. And if you add all of them, then definitely you will get the effective velocity of the first one with respect to last one. You have to do the vector addition, but during the vector addition also, the substitution of the values must be as per the sign convention. Substitution must be as per the sign convention. Let me extend this further. Its extended version. I'm writing here. Extended. So I can write it as VA, see, V1 with respect to 2 plus V2 with respect to 3 and so on. If I write velocity of n minus 1 with respect to n, see, I'm doing vector addition. I'm doing vector addition here, but during the substitution, I must be keeping the plus minus sign in my head, or maybe I cap, j cap for 2D motion. Okay, so if I add all of them, then definitely I will get what is the velocity of the first one with respect to last one. What is the velocity of the first one with respect to last one? So this is V1 vector with respect to n. V1 with respect to n. All right. Keep moving, 1 on 2, 2 on 3, 3 on 4, 4 on 5, you will get 1 with respect to 5. First one with respect to last one. That's what the conclusion is. I hope the confusion of relative velocity and effective velocity will not arise in your head anymore hereafter. Let me know, did you get the feeling difference between the two? Two objects are moving individually, stand on any one, observe the other one. Relative velocity involves vector subtraction along with the plus minus sign. Okay. If one is moving on the other is moving on another is moving on another, then velocity of first one with respect to last one will be given by the vector addition. Again, the addition must be done along with the plus minus sign as per the convention. Hope that is clear to you. Let me know in the comment chat section. Is that understood? Niharika, the effective velocity, Niharika is saying the effective velocity is the algebraic sum of the actual fluid velocity and the velocity with which the flow meter is moving as determined by the cable speed. That is one of the examples of, yes, appropriately mentioned. That is one of the examples where we use the effective velocity. In riverboat problem also we will use the effective velocity. Okay. Rain umbrella problem we will use the relative velocity. So every time the topic is same only, but my wordings or sometimes my usage of sometimes doing vector subtraction, sometimes doing vector addition would have bothered you. But now I think it is crystal clear. Yeah. All right. Understood now? Chalo, let's move ahead. A quick recap before starting the problems now. Some more problems now. So relative motion in kinematics we have started today. We have understood what do you mean by relative motion when that comes into the picture. When there are two objects, both of them are moving. You want to stand on any one, observe the other one. Then velocity of object with respect to observer is always given by the vector subtraction of velocity of object and velocity of observer. All right. And 1D, 2D, 3D, any type of question can be there. All the questions that can be done with relative can also be done without relative. It is just a tool or a technique. So let us be interested and let us have a good enthusiasm to learn that technique, because whenever I say technique, obviously it is meant to simplify the dealing of crucial problems. All right. One short recap: relative velocity in one dimension. If the objects are moving in the same direction, their relative speed will be given by the difference of the two. If they are moving in the opposite direction, the relative speed will be given by the sum of two. Yes, it will be relatively faster when moving opposite. The objects will be appear to be moving relatively slower when moving in the same direction. Okay. Problem models based on relative motion. First one is time of crossing, which we just now have seen already. A quick recap I'll give. Time of approach or meeting, that is also in our list. Riverboat problem we'll do tomorrow. Rain umbrella problem we'll do day after tomorrow, like on Monday and Tuesday we'll have our sessions. And the remaining problem models also I'll keep discussing with the topics. Confusion of relative velocity and effective velocity. Relative velocity is given by the vector subtraction. Effective velocity is given by the vector addition. Feelings behind them is clear to you, but whether you are doing vector subtraction or vector addition, that must be done as per the sign convention. Remember all my words till our next discussions. I should not keep repeating them. You should be feeding them in your head. Okay, that's necessary. Now, time of crossing. Both the objects can be moving, single object can be moving. The total length will be the distance to be traveled in order to cross. Effective speed or relative velocity may be added or subtracted there, like in terms of speed, depends on whether they are moving in the same direction or opposite direction. I hope that's clear to you. Let's talk about few questions now. Yeah, so we do have practice problems with us. The target is for NEET 2026. But slowly today, because we have just introduced the concept of relative motion today. So slowly we will go ahead and we'll develop our fundamentals. So that is the first question in front of you. Okay. 2 trains, each 50 meter long. You can keep trying. I hope you are sitting, you're not sitting and watching it like a movie, but you are sitting with a pen and paper, rough paper, and you can keep doing the problem side by side. 2 trains, each 50 meter long, are traveling in opposite direction with velocity. See, the main keyword in the problem is they are moving in opposite direction. And then they are asking the time of crossing. Time of crossing. To see what you can write. Time of crossing will be 2 are the trains. So it is L1 plus L2. They are moving in opposite direction. So in opposite direction, that should be V1 plus V2 or V1 minus V2. Opposite direction, relatively faster. The relative speed is given by the sum of their individual speeds, V1 plus V2. So L1 plus L2 is 50 plus 50. V1 plus V2 is 10 plus 15. Everything is already given in SI units. Options are also in seconds, SI units. So that is 100 meters by 25 seconds. And hence the answer is 4 meter per second. 4 meter per second. So, sorry. This was in meter per second, my bad. This was already in meter per second. You are finding the time here. So it is 4 seconds. Option B. All right. Manideep said 2 seconds. No, that's not correct, dear. You have to consider both the lengths, right? L1 plus L2. L1 plus L2. That's what we have learned in time of crossing. All right now. Very nice. Question number 2. A police jeep is chasing with velocity 45 km per hour a thief in another jeep. So let us say this is the police jeep chasing with velocity of, a police jeep is chasing with velocity of 45 km per hour. Okay. A thief in another jeep, and generally the way, police is slower, thief is faster. The question is also sharing the same data that thief is moving with 153 km per hour. See, these data are not in SI unit. Police fires a bullet with muzzle velocity of 180 meter per second. So the bullet is fired, velocity of bullet. The bullet is fired with a muzzle velocity. Muzzle velocity is with respect to gun. This term, muzzle velocity is with respect to gun. With respect to gun here. Okay, the velocity of bullet with respect to gun. The velocity it will strike the car of the thief is the velocity with which it will strike the car of the thief. So here we are interested in velocity of bullet with respect to thief. They are asking us velocity of bullet with respect to thief. Okay, so I'm writing it as velocity of bullet minus velocity of thief. See, what they are asking you is that with what velocity the bullet will hit the thief's car. So according to thief, no, I'm not the thief. According to the thief, I'm the policeman. Right, I'm firing. According to the thief, with what speed the bullet is hitting the car. Right. So I would say velocity of bullet with respect to thief. According to thief, we are finding the velocity of bullet. But the issue is that this velocity of bullet, suppose I want to write the frame of reference. So I write it as ground, and this must also be ground. As I said, these two must be with respect to the same third frame of reference that may or may not be ground. This time, thief's car velocity is always with respect to ground, right? Thief's car velocity is given with respect to ground, but bullet's velocity is not given with respect to ground. Bullet's velocity is given with respect to gun. So I will write it as velocity of bullet with respect to gun plus velocity of gun or police, because policeman is holding the gun in his hand. So velocity of gun or police with respect to ground. See, we wanted the velocity of bullet with respect to ground. So what did we do? Velocity of bullet with respect to gun plus velocity of gun with respect to ground. So that will give you the velocity of bullet with respect to ground minus velocity of thief with respect to ground as it is. This is as it is. All right. So what the beauty of this problem is that in the same question you are getting to deal with relative velocity also, and then you are getting to deal with effective velocity also. Understanding? In the same question you are getting to deal with relative velocity concept, vector subtraction also, as well as effective velocity concept, vector addition also. All right. Now just substitute everything as per the sign convention. Since everything in the diagram, rough diagram I have made are forward, so I'm going to take everything as positive. So velocity, but in the same units. See, all the four options are in SI unit, but this is in kilometer per hour, this is in kilometer per hour. So velocity of bullet with respect to gun is 180 meter per second. It is already plus 180. Plus this plus because of the formula. And the velocity of gun with respect to ground or velocity of police with respect to ground is also forward. So that must be taken as positive. Positive of 45 multiplied with 5 by 18. 5 by 18. This minus because of the formula. But according to the substitution, like according to the sign convention, the substitution must again be positive. So positive of, this is 153. 153 into 5 by 18. If you want, you can further solve it. You will get the answer. All right. So what is so important? The first problem I took very simple, but this second problem I have taken, what is so important or what is the beauty of this particular problem? In the same problem, we are going to deal with the relative velocity as well as the effective velocity. But our way, this is general way of doing it. Way two of doing it is also there. This way 2 is feeling based. Now what do you mean by feeling based here? See, it's physics we are studying, right? Physics hai, you must be feeling it. That too mechanics. Everything is happening around you, you can feel that, right? So they are asking velocity of bullet with respect to thief. Basically they are asking that is velocity of hitting. They are asking velocity of hitting. Okay. So I will just say whosoever tries to hit, there are three velocities in the picture, right? Police velocity, thief's bullet velocity and thief's velocity. And you are effectively interested in velocity of hitting. So any velocity that contributes or that supports the hitting must be taken as positive. Any velocity that tries to escape out must be taken as negative. Okay. So the police desires to hit the thief or not? The police wants to hit the thief or not? Yes. And you are interested in velocity of hitting. So that will be positive of 45 into 5 by 18. Positive of 45 into 5 by 18. The bullet wants to hit the thief or not? Yes. So positive of 180. The thief wants to get hit or not? No, thief wants to escape. So minus of 153 into 5 by 80. Okay. doing after all this relative velocity, effective velocity, then also you got the same conclusion, na yaar. You got the same conclusion. All right. So that's why I said our way of doing it is basically feeling based. We have understood the intent of the situation. The intention of the situation is that the bullet must hit the thief. So all the velocities which are portrayed in the diagram, which are mentioned in the situation that supports the hitting, must be taken as positive. All the velocities that are supporting the escape or preventing the hit, that must be taken as negative. I hope you have enjoyed the way to feeling based. Just have a look. Yes, Chandu, it is supporting minus opposing. Right, very nice here. Everyone got the answer? Can I rely on your calculation? Everyone is getting 150? Yes, everyone is getting 150 meter per second. Very nice, dear. Very nice. Let's talk about another one. Right, that's a NEET PYQ already. Preeti reached the metro station and found that the escalator was not working. One day, Preeti reached the metro station and the escalator was not working. But Preeti has to go. So what she would have done? She started walking over the escalator with her own speed because escalator is not moving. And the time taken by the Preeti to go from one floor to another is T1. That is given in the situation. She walked up the stationary escalator in time T1. On the other day, if Preeti is tired and Preeti remains stationary and the escalator is moving, then it takes T2 time. If she remains stationary on the moving escalator, then the escalator takes her up in time T2. The time taken by her to walk up the moving escalator will be, if Preeti is also moving and the escalator is also moving. If Preeti is also moving and escalator is also moving, then definitely she is going to take the least time. She is going to become faster. All right. So I'll do it again by two methods. Way one, common way of doing it. There are three situations given to you. So this escalator is not moving. This is, situation number one, day one, velocity of escalator is 0. And the Preeti, let's say I have drawn Preeti like this. Preeti is moving with VP, velocity of Preeti. And suppose the distance traveled from this floor to this floor, like this length is L, and here the time taken is T1. So here I would say T1 will be equal to the length L0 by VP. The length L0 by VP, day 1. In day 2 situation, what is happening? Preeti is not moving. The VP is 0 and only escalator is moving, VE, and it takes T2 time. So T2 is going to be equal to L0 by VE. L0 by VE. On day 3, when both of them are moving, so can I say this is T1 given to you, this is T2 given to you, or let me write it like this. Right, the situation is this, see, that T1 is also given to you, T2 is also given to you. Let me inbox it here. These data are given to you here. Now on day 3, what is happening? Preeti is also moving and escalator is also moving. So T net will be equal to the distance you are supposed to travel is again L0, but this time both will be supporting. So VP also plus VE also. So that will be equal to L0 by VP can be written as L0 by T1 from the first one. Here it can be written as L0 by T2 from the second one. See, L0 got cancelled. After taking the LCM, denominator will become numerator. So it is T1 T2 by T1 plus T2. T1 T2 by T1 plus T2. This is way 1, mathematical way of doing it. Logical way of doing it is our way, way 2. If both are moving, then time taken will be least. Time taken, because if both are supporting the motion, it will be like Preeti will reach one level to another level earlier. So you'll say time taken will be least. Process will be faster. All right, time taken will be least. Now let us try to understand the options here. It is the average value, T1 plus T2 by 2. It is the average value lies between T1 and T2. This final answer will lie between T1 and T2. It is T1 T2 by T2 minus T1, but because of negative sign, you must be eliminating this option. Since time cannot be negative, we don't know whether T1 is more or T2 is more. We don't know whether T1 is more or T2 is more. So if we are not sure about it, it may result into negative time. May result in negative time. Same here, I will say it may result in negative time. But if you try to focus on this one, just like parallel resistance, R1 R2 by R1 plus R2, and parallel resistance is least smaller than the smallest one, and reduced mass, just like parallel resistance and reduced mass, M1 M2, like this is R1 R2 by R1 plus R2, it is smaller than both, and it is M1 M2 by M1 plus M2, it is smaller than both, M1 M2 by M1 plus M2, reduced mass, that's why the name is reduced mass. We have here as that T equivalent will be less than T2 and it will be less than T1. If it is less than T2 and less than T1, then definitely option C will be your final answer. So what did I do? Either I can solve it by mentioning the situation diagrammatically, solving it numerically, or else I could have just analyzed the option. I could have just seen the possibility that which options are possible. And if I use my logics precisely, then definitely without doing all that stuff, you can directly hit the final answer. I hope you would have enjoyed the logical approach of doing that problem too. And that's already one of the good problems of NEET PYQ and one of the common doubts of students. Is that clear? Did you enjoy the today's session finally? All right. Okay, the question is, sir, why we can't use V3 is equal to V1 plus V2? Indirectly, we have used the same. Okay. All right. So that's it for now. Just make sure, because this is the last session for this week. Tomorrow, you will not have any session. Monday again, we will be meeting and we will be continuing our session of this bridge course. But make sure whatever we have done the entire week, you revise it thoroughly. All right. Take a small break, then you can resume with your chemistry lecture. Okay. Thank you so much for your patience. All the best. Bye-bye. Have a nice day.